Friday, or did nobody reply?
Nobody replied, so I was like, okay, they got it.
Definitely appreciate the opportunity that they gave us.
Thank you.
Needed it with this class.
Try to. It's a hectic time in the semester for us with looping, and we'll start on modules, so it can definitely be a lot of knowledge.
People have actually dropped out of this class yet?
No, we're going to start dropping some, I tell you.
So soon the dropping of flies will be in.
Do what?
So soon some will be dropping like flies.
No, actually, most of our people that have had to be working from home have been doing just an outstanding job. It just makes us feel weird when we're here. So like Elijah. Are you Elijah?
No, Elijah, I think he's at home or something like that.
Right, and so I'm looking and like, he doesn't, Elijah, you don't have your name marked as remote in the Zoom session, so I'm looking around here trying to find you, questioning
Can you hear me?
whether I know people's names or not. So please add -remote to your name in the Zoom session for me. It's quite difficult to keep track of everybody. So I appreciate that little update in the Zoom session so I can tell where you are. Jason, are you in the same situation? Do you need to update? Oh, look at him, he got it. Thank you, sir. Who else have we got that's at home? I do wish kind of that Zoom would show him in alphabetical order. Would that be nice? So I haven't griped at everybody saying, please put in your name this way, because it doesn't put them in any order anyway. I'm going to share my screen so they can see what I'm griping about. Then they can't see it. Nope, can't hear you, Elijah. There's Jessie Whitaker. Let me mark you as here, but not here. So I'm going to count absent today. I know you guys that are here don't care. I just want you to tell me if I'm counting you absent, and I shouldn't. Jessica Webb. Zach Brake. Felicia. And Alexander. Yeah, we normally have more people showing up in our offsite. We'll see. So yeah, as a whole, you guys have just been doing an outstanding job being a hybrid class, and a whole bunch of you having to work from home off and on. I think everybody's been doing a really good job at keeping up. Now, as we finish the last assignment that was a group assignment, I do want you to work with your groups and rely on your group. And I know it's difficult when some of them are here and some of them aren't and all those kinds of things. Let me see if I can, I'm going to bring Canvas on the screen, and I'm going to try to set it into student view so I can see what you're seeing, hopefully. Yep, like I've got stuff that I haven't cleared. I'm gonna have to go through. I'm way behind on my marking things as done and all that kind of stuff. So I better leave student view or we'll never get anywhere waiting for me. Make sure you're keeping up with all of that because you should be seeing week 11. We are at week 11 this week. So since we have a 16-week semester, you know, we're really getting close to the end. 2/3 of the way through at least. So we've had a lot of learning behind us. We have some more learning ahead of us. Some of our time ahead of us, so will be like kind of solidifying some of our ideas and concepts that we've learned too. Remember, I'll say it now and I'll probably say it again. If you were in college to become a brain surgeon, you wouldn't expect to perform surgery after your intro to surgery class. So that's the same place you are. You've had your intro to programming class where you're halfway through it. Some of you have more experience than others, of course. But you shouldn't expect for yourself to know how to solve every problem and how to do everything. So it's okay to not be. And this field does require a lot of ongoing searching for knowledge. And that's why we get paid a lot, because it can be kind of stressful to not always know the answer right off the top of your head. But that's why developers get paid so well. So last time we were looking at chapter 6, and chapter 6 was kind of an extension, more looping functionality. We saw how we could use some loops to validate user input, keep requesting input from our users until they gave us valid data, how we could run loops a certain number of times. And then we took a real quick look at this begin a quest assignment. And I told you that today we would have lab time for that. Well, I want to kind of back up that train and reevaluate, because I think that we can do a lot better job on this quest assignment if we have a little bit more knowledge about subprograms. So I think we should go ahead and talk about subprograms or developing functions, because you guys have been using all of the built-in functions like round and string and all of those kinds of things all along. And we've created functions of our own as we've gone too. Sometimes we focused more on sequential code, sometimes on splitting things up in functions in a modular approach. But I think that you'll be able to give each other assignments in this quest project easier if we are really clear on splitting things up into functions. That way, if you have one person that isn't here, you can say, you need to work on the, create an award or plaque function or whatever we're going to call that. And someone else needs to work on this treasure function, and we can put them all together then. Before we get started though, looking at that other stuff, I had some people ask for some questions and help about the notebooks. So we can't spend much time on that or we'll be kind of off the ship. But it doesn't do us much good to go on forging ahead if we have problems. So what kind of questions would you guys like to look at before we move ahead? Let me get logged in while you're looking for them.
Actually, I got one about it.
Good. See if I can figure out how to find my stuff.
Speed run into Google Drive.
I think I found them. What have you got? Let me bring that thing up. So I'm going to bring up the chapter 6 one. Here's my one for this class. Get it found. Where did you have a question?
6 point, yeah, example 6.5.
Great.
Yeah, so it, so activity 4. So basically, so what I did is, because it says to declare number as float.
Uh-huh.
I did that, but later on, it wasn't allowing me to basically count number as a float, and so I had to put it later on as like sounding as integer. So because I had to do the int, colon, and the numbers.
Can you share with us?
Yeah, I
Let me stop so you can take over. Elijah, remember. Elijah, I am not going to remember. I need you to put the word remote by your name as I've requested, please. Thank you.
So, because like up here,
Uh-huh.
the numbers float, so I did that. But then
That looks good.
So later on down here, I tried doing if number is greater than equal to 0.
Well, let's look at your number variable. Can you select it up there? What I'm wondering, does Google Colab do any sort of auto selection if you select that word number? Some of our editors will. We could do a find on that, right? Can we do Control F like we could if we were on a website to try to find something?
Yeah.
And so let's type in number and let's see where all we find that variable. And of course, we're going to find it more than just this cell, but it has highlighted it for us, and that's what I want. Perfect. Are we in the right one?
Yeah.
Okay.
So
Perfect. So we're looking at it here and it highlighted every spot we've used that variable or that word. So it looks really good setting it up, you said, as a float. But then what happens with our input statement? Yes, you had a different thought. Go ahead, show it.
Oh, no, I'm good. I'll wait.
You're going to wait.
I figured it out, so it's like a,
Ah,
The input is interesting. So the input.
right. Right now, we just have the input function. So that's going to give us a string. So
Oh.
Python's like, well, I thought you wanted number to be a float, but okay, this is the first time you're using it. Obviously, you want it to be a string. And so it's just going to switch it to a string because Python is really sweet like that. It says, well, if you want to use it like a string, so we don't want it to be a string, do we? Nope. So
Oh, yeah,
this one
sorry,
down
sorry.
here.
Accidentally, I just mixed words in my head there.
Yeah, I know what happens to me up here where I'll be thinking of something and I'll say it and it's not what I wanted to say, but it's what I was thinking. So down here, your if statement was good. It's your input statement that's our problem.
Okay.
So in our input statement, we want to wrap that in a float.
Okay, so rep, so like.
Put float in your open parenthesis. So our float is a function, and we know that with a function, or we're going to talk about it a lot today, the things we pass to a function are enclosed within parentheses. So now we have the input function enclosed in the float function. Now run that and see if that takes care of. What else? Take the other thing.
Response should have integer.
Response shouldn't be an integer. That's true. That's going to cause a runtime error, isn't it? Right above your cursor on line.
Oh, right, thank you. Okay.
12, 13. So get rid of that int function in that one. On line 13.
Oh,
Anything else? Oh, you eagle eyes see? Beautiful. That looks good.
makes a lot more sense. All right, thank you.
Thanks, everybody. Any others? Not problems? Anybody at home have any questions with any of theirs?
I've got one if no one at home has anything.
Sure.
I think I keep getting confused with the counting. Every time like it's calling it something it's called.
Mhm.
And I don't know if maybe I don't know. I don't think it's outputting correctly, but
Can you show us?
okay. Look at my code.
Let's see that code. They're gonna pick it apart.
All right.
They're nice.
All right. Yeah, it's question number 6.9. You can see whenever I do my output down here, I got a count of 3, even though there's 4 letters in my name.
Oh, uh-huh.
And I don't know, like I keep coming back to that whenever we have to do like counting and things like that. I keep running into, I don't know if I'm actually outputting it, like with the beans one we had like a couple weeks ago.
Right.
There were so many beans, I don't know if I had the right amount of beans.
Well, if we look at this one in your while loop on line 17,
Mhm.
there's always that decision to make. Do we want the loop to execute one last time when the numbers are equal? Because with it set to less than or equal, what's it gonna do? Is it gonna execute that one last time when they're equal or not, depending on how your test is set up? What's going on here? Well, the count is less than the or equal to the number. So our count is the thing that's increasing, right?
Does that help any? No, that made it worse.
If you do control scroll, it'll
Oh,
zoom.
yeah. That's too much? All right.
No, that is good. What do you guys see? A problem there? Can you tell? So the question is, why is he getting 3 of the symbols printed out instead of 4? Because the name entered is 4 letters. So when we start out, we're inputting that name, asking for the symbol, space. Then we're using the len function to get the length of the name. And while our count is less than or equal to that number, we're printing out our symbol. I'm not seeing it. To me, it looks like we should be getting, what do you see?
It's less than equal.
Less than what?
0. It's less than equal when it starts with 0. So it'll do 1 more. So if you set count 1 or 7, it's less than 0.
Are you assuming he's picking a space? Is he picking a space?
Are you talking
Oh,
about?
yes, he is
like,
picking a space.
Oh,
So in this example, that's exactly what it is. I'm looking at the problem in one way, and Seth's looking at it in another way, and I'm not sure how you're describing it. So we could have 3 descriptions of the same problem. It's a normal thing. So since when we run this, we're choosing yes for a space. That's kind of messing up our output, right? So are we really getting 1 less than we should, or are we getting 1 more than we should?
I have to don't
Tutoring
call.
is, tutoring is
The
no.
length it'll
Per space.
is length of it. You start at
Seems to be
zero,
the right
it's
amount
less
of
than equal
flow
to the
for
zero.
Yeah,
So
you're on it.
zero,
Yeah.
1, 2, 3, 4, that.
yeah. So what Seth is saying is you're actually getting one more than you should because you're getting, you're including the space character.
Well, same as if
So
I put
that's
no.
to say, no, we don't want a space.
Okay,
If I put no, it'll add one more.
then I have 5.
Right, so now you can see the real problem.
What is the real problem?
You are doing it one time too many.
So would,
So
in my
what
if,
could you do?
in my if statement, should my count be plus or equal to 1
Instead of two, like that.
instead of?
You have some choices. You could start your count variable at 1
Okay,
instead of 0, since you're really looking at that first character. Or you could change your while statement to just be less than and not include the equals if you want to start your count at 0. So your solution is up to you.
I think I would rather, in this instance, say you were presented with this string going, would you prefer to change the variable count, count equal to 1, or equal to 1, or would you go into the code and change
It's
it?
really 6 of one, half a dozen of the other.
Okay,
I would prefer to start the variable at 0 because we're programmers and we start with 0. And so then we would change our while loop to not include the equal condition just because we normally start things at 0, but that's not a rule or anything. Either one is perfectly fine.
well, that didn't work, but I still got 5.
So we're starting with our count at 1. Wait, number 9, if I have 2 equal signs, that's a comparison, not a setting of variable. We don't even need that line. Let's get rid of it. That's what we would use in an if statement, 2
Oh,
equal signs.
yeah.
So we only need to set it to a value of 1. Right, now let's try it.
Hey, look at that.
Woohoo! Good eye, Seth.
Good.
Because I was like, I don't even know.
Yeah.
Doing one less. Now try putting your space in and make sure that you get fewer. And then we need to do one other thing to this program before we're done with it. I'm glad you brought this one up because this one is one that you can use for your quest. So we can use this function in our big quest program that we're going to work on.
For spaces, you should take half of it.
There we go. So now it would be nice though, if those were right under your name instead of coming down. We want them to be a border. So how could we make it to where we don't get a new line every time we go through? We need to use a variable here instead of printing each time. So
I did find a way within the print statement.
did you?
Yes. I can show.
Yeah.
Let's see that, because that's going to be less disruptive to everybody. I want to see it.
Looking it up, I found that Python, after any print statement, automatically does a new line.
Mm-hmm.
So this is different than C++. So you're going to actually stop that. Let me zoom in here. So the print symbol end is actually how you're going to do it on the same line.
Really?
And I use for loop to do my iterations here instead of a while loop. Let's see, I'll run it for you. But that right there, print symbol end is all you need to do. And I'll have it right underneath.
So when you print, when in your else clause, where you set the end equal to that empty string, that forces it to actually do the print of everything that's been accumulated. Is that
Print, the print symbol or the print now, how does it look?
where
print
it says
symbol?
end equal?
And equal, okay, so that's the for loop.
Mm-hmm.
And then we got the lean, I'm counting the number of the, your input for your name.
Mm-hmm.
Symbol and, on both of them, for and the else.
Well, let's see if we can convert that to his code, because his is a little different.
But
So-
on your code, where you're using the print.
Justin, let him bring his back up,
symbol,
would you?
He doesn't.
Can you let him
All
share?
right, let me start.
Sorry. Thank you so much. That looks so good. We'll see if we can do that in
Just modify your print, your print, statement.
Cody's code. So right there.
Yeah, there you go.
So we want to change that a little bit though. So in your second print statement in your else clause, that's where you want to have comma and equal.
So I don't want it up here.
No, you want it in both.
Oh, okay.
Equal, double quote is what Justin had. So like say, without a space.
You have no space there.
No space in either of them?
No, just in this one.
Okay.
Because this one is saying, basically, the ending is empty, don't end this print statement. Just keep adding stuff.
Okay,
And then when it finds the empty end, it says, okay, now print all that stuff. So it's been accumulating the things to print, and when it finds that empty end, it should actually send the print.
can't go in.
I'm not sure that actually accumulates though. Isn't it still gonna run through? It's just printing on the same line. On the for loop, at least, when I was using the for loop.
Right, well, no, because it's using this code in outputting the symbol to a buffer, keeping all of those symbols in that buffer. And then when you do the print statement with the empty end, it pushes everything in that buffer out to print. So let's run it on that visualize site. Can you copy it?
That came in handy. I went back to that.
It's really
Still have to
helpful.
add that, yeah.
It helps me a lot with other programming languages too.
What was that called again?
So it is pythontutor.org. Oh, it popped up, I think. There we go, and then let's paste it. So I don't know what we'll be able to see with this end parameter to our print statement on the visualizer. We'll see if we can tell anything. So as we start out, we're setting up our variables. Cody's going to type his name. Now we've got that in as one of our variables too. Now he's going to enter in his symbol. And now he's going to output that message. Do you want a space?
Yes or
And
no?
answer it. Either one's fine. Now we're going to print out his name. And now we're going to go into our while loop. So the first time we look at our while loop, our count is less than our number. So we're going to look at our if statement. If they chose yes, that they want to keep going, we'll go ahead and next there. We'll see it print out what was left over from last time, which was nothing because this is the first time, so keep going. Keep going. Now we're back to our while statement. We are still sitting there with our count less than our number, so let's next. Let's keep going. So we're just adding
Oh,
to
I
our
see.
print
Yeah.
output.
So, got three there.
So
but we're-
it's adding it. We wouldn't see it. So keep going until we finally get. So now when we finally print, we're going to see everything that was left over in that print buffer. So it prints out all of those symbols. Now, if you click next again, where are we all done? Should be.
All done.
We see that, how does that look message? Because that one came out then after we printed. Now, what we could do otherwise in this example, this one is a really good one for us. In this example, if we didn't want to search for how to handle that print, which one was that? That was
6-9.
there it is. If I can find it. Oh, I don't have it. We're gonna have to share yours again. Can you share yours again, please, Cody? I forgot. Mine is empty. It's missing the answers. I'll have to get those. So scroll down and let us see that, or did it disappear? We're looking at mine. I gotta let you share. In our while loop, we could have set up a string variable, and every time we go through our while loop, then we could add that symbol to our string variable. And then when we were done with our while loop at the very bottom, we could print out that complete string variable that has all the symbols in it. So just kind of think about that, that we could use a variable to hold all of those. And every time we go through our loop, we could say string variable plus equal the symbol, so that we're adding a new one in to that variable, a new symbol. So when you're working on the quest assignment, try some things like that. It's just a really good opportunity for you to experiment with adding items to a string so that you can output everything all at once. Thank you guys, that one was great. I'm going to take it back. And questions from home. Some definitely complicated, good problem solving there. Okay, if you feel like you still have issues with that, week 9 or 10, where are we? The looping Colab notebook, do let me know. So I can help you with it. Like Justin mentioned last week, I did post a message that if anyone was interested in a tutoring session to message me, and we need to make sure that we're taking advantage of opportunities like that. So you guys are just a hybrid class. Sometimes I am rushing through to make sure that I've conveyed the information to you. So you should never be ashamed or embarrassed if you have additional questions. You should just ask them. The other thing that you can do, I had a former student come over yesterday and we were meeting about something completely separate, but he happens to work for the tutoring center. And I asked him about it. I said, you know, I got an email from an advisee. It wasn't a student in any of my classes, from an advisee saying, I tried to find the tutoring center and I couldn't find it. And he said, yeah, it can be kind of hard to find, but they have online tutoring available for the 120 classes. So on your dashboard there on Canvas, if you just go to the online tutoring section, he showed me somewhere, oh yeah, if you click here at their website, they have some great information about the schedule of availability for the different tutors. So they have it kind of fancy set up like a mobile app. So for computers and computer applications, they've already updated this week as far as what time and day there will be online tutors available. And you could add CIS120 to this list that they have of CIS classes, because remember, all of these people that are tutors that know how to tutor the C# and Java classes are probably going to be able to help you with some of your Python concepts. They might not know Python though, so that's why they don't necessarily list the 120 class, because we do have different instructors that use different languages. But the tutors are going to be able to help you tremendously, just even asking you what questions you should consider. Like, have you thought about this? Where did you look for that? So they're going to be able to kind of help you with that. So if you need that support, don't forget that they're out there. And he said, you know, we just haven't had many people this semester. Everybody in their 120 classes isn't needing much tutoring. And then as we were talking, we thought, well, maybe they just can't find it. So make sure you're looking. And then on site, they're over in ICE. So this half of the giant building, but they're upstairs and it's kind of a maze up there. So you can always just ask someone where the tutoring center is. And I didn't realize, he said they had more than one tutoring center now, like they've split up. So one area does certain classes, like English classes or something, and then there's another area that does computers. And so you might have to dig around to find them a little bit, but it'll be worth it. Like DJ told me, he said, we don't teach people like the teachers do. We use tutoring concepts. So they really use some different concepts to try to make you think about the information. Okay, so let's look at chapter 9, our subprograms. Like I said, I think this is going to help you with your quest. And I did add it to this section, this module again. It's the same exact assignment as it was in last week's module, just listed again. So let's open a few things. First of all, I want to take a look at the very beginning of the textbook PowerPoint. So I'm going to open it. The other PowerPoint that's posted for this chapter is kind of a walkthrough of taking like a program that's been written in a sequential top-down manner, like we've been doing in the last few chapters, and converting that program to a modular program with functions. So you can refer to that presentation if you like. We won't go through it together. Now let's look, first of all, when we look at this chapter, chapter 9, we're skipping a couple of chapters, right? We just did 6. So we're skipping things about arrays and lists, and we're going to go back to those, don't worry. But that means that there could be an example or two in this chapter that might have some code, some syntax that you're not familiar with. And I've tried to just keep those examples out of our Colab notebooks, but just be aware that you could see some code that you're not exactly clear on yet. So just kind of file it away for something that you're going to be learning about soon. Whenever we started the very beginning, our textbook talked about modular programming. And we started out, if you remember, with functions, and we were using global variables. And then our textbooks just sort of fell flat on us, and they just went back to this top-down code. And they were like, well, beginning people, they just can't understand these modules. I think you could have, but we needed good examples, right? So now we'll be able to look at some good examples with some modular code. We saw then that it's better. If we're working on this Quest application, if we use different functions, you can assign different members on your team responsibility for different functions. We could have done that already with what we've been using with our functions with global variables. But I want you to think about it. If we're using a global variable, that same variable is used throughout our entire Python script. So that means that if Joe is coding the request the user's name function, and Amy is coding the surround the user's name function, they have to both use that same global variable. They have to trust each other with that global variable, right? Nobody's going to abuse it. Everybody's going to update it the way they're supposed to. They become dependent on each other because we're all using the same global variable. So what we want to do is make our functions totally standalone, kind of like a black box. So if you think about a fancy graphing calculator, they have functions, right? You can call a function to do the square root. That's the exact kind of function we're talking about. A piece of code, a chunk of code that accepts input, does something with it, and spits out some sort of answer. Or in some cases, that doesn't even spit out an answer, just does something with the information. But that's what a function or a subprogram or a module is. Whenever we're looking at terminology, different programming languages are going to use different terms for these subprograms. All a subprogram is a chunk of code that's logical, right? It belongs together. It does some function. So we've separated it out from everything else, from our other code. We can give it a name and we can take care of it because it does something that's important to us. But just like each program we looked at the very beginning, we said a program's going to need input, then it's going to do some processing, and it's going to give us output. A function could be exactly that same kind of thing. Could require input, do some processing, and give us output. Well, in Python, we're going to call these subprograms functions, right? In some programming languages, we might call them subprograms, subroutines. In C# and Java, we'll call them methods. So these subprograms have a lot of different names, modules. Basically, we're always referring to the same thing, just a chunk of code that's been separated out that can be executed repeatedly. So whenever we're looking at global variables, we can access the global variables through all of our different functions in a program. But if we start really trying to make those functions stand alone, where they're not dependent on each other, then we have to start transmitting data between our different functions. We can't just all share that same global variable. We have to pass information back and forth from one function to another. So we're going to use parameters as the input to our function. We're going to use data flow diagrams to try to keep track or document what data is transmitted to and from each of our subprograms. So if we have to pass some data into a subprogram, we're going to say that that data is imported by the subprogram. And then if it comes up with some sort of answer that it needs to return back, we're going to call that data that's being returned to us is exported data. So inputs are imported, outputs are exported. Whenever we need to import that data, we'll say that we're going to pass a value to that subprogram. And that's just kind of our terminology. Well, we're going to pass a value to our subprogram. If we want to use the square root function, we know the value that we're going to pass to that square root subprogram is the number that we would like a square root of, right? So we know how that works. Here's the data flow diagram. If you remember, we started out in chapter 2 or so with a hierarchy chart. And this is just a hierarchy chart that's had some data attached to it. So let's open our Colab notebook because I think I have this thing in there. And then you guys can do some stuff. So for week 11, it's going to be the chapter 9 notebook. And then once you get it open, let's save a copy in your drive. And I'm going to put our class in here for me. So as we start this one out, you can see the important things in chapter 9 up here at the top. We want to remember what data flow diagrams are, and we're going to be looking at arguments and parameters, passing our information to our functions. We're going to talk about the different ways we can pass data to our functions. And of course, we've already talked a little bit about global variables, and global variables have a global scope, meaning that I can refer to them anywhere. So let's look at our sale price program pseudocode. I'm going to get rid of this table of contents for a second. And in our chapter here, we're going back to the sale price program. I'm going to scroll past that pseudocode to look at this data flow diagram. This is the one that we started out with pseudocode on the very beginning of our semester. And we said that we're going to have a main module. It's going to display a welcome message. Then it's going to ask for input. The input that it's going to ask for is the original price and the discount percent. Remember, this is something's on sale. That data that we get in our input data module, if we're going to make these things really stand alone and not dependent upon each other, then that data needs to be passed back to our main, and that would be our original price and our discount rate. Now that our main knows what the original price and the discount rate is, it can pass that data to the compute results module. The compute results module can import those two data items, do its calculations, whatever it needs to do, and then it's going to return the sale price, because that's what its job is to compute the sale price. So it'll return that to the main module. So now our main module knows what the original price is, it knows what the discount rate is, and it knows what the sale price is. It can pass all that data to our output results module to get everything printed out. So when we look at this and we see that we're going to have to be importing data and returning data and worrying about where things go, we're going to be a little more complicated than we were just using a global variable for everything, right? Because now, instead of variables that are up here above our main, that are global in scope, that we can use in any function, now we're going to be using local variables that we can only use in the function that they're known to. So that's going to change things up for us a little bit. I'm going to back up. And up here at the top, I have the pseudocode sort of that they want for the sale price program. Some of it is pseudocode, some of it is English-like language, some of it is more code-like than others. And that's how pseudocode starts getting, right? Because I start out the beginning of the semester saying, your pseudocode should be written this way. Of course, actually, I tell you guys, it's pretty flexible. Not anybody gonna say that you didn't follow these rules. But as we get more and more developed in our knowledge of programming, our pseudocode becomes more and more flexible. Kind of just notes to remind us what we needed to do, right? So we're getting it all put together there. All right, so we have this data flow diagram. We are going to need to be able to pass all of this data, the original price, discount rate, and sale price, all to our output results function. So let's do a practice function that'll kind of be like our output results. That's what example 9.1 is. We're gonna put this one in. And I've already got the answer there for you. How nice is that? Let's take a look at it. In this one, the reason that I already have the answer for you is multifold, many, many reasons. First of all, if we look at the pseudocode in our textbook versus the Python code, there's a lot of differences, right? Let's take a look at this Python code. In the Python code, in our main module, our main function, we set up some local variables, old price, rate, and new price. And I had some students that were having a lot of confusion about declaring variables because our pseudocode always shows that data type. So I found that if we use the data type and then supply our value, we can make it a little bit more similar to our pseudocode. We wouldn't need to do that, but we can. So here's our variables. And then we're calling our output results function, and we're passing the data contained in those variables to our output results function. Here's our output results function. Remember with Python, the function has to be declared before we can refer to it. So it has to come above the main. And in our function, we say, I want 3 data items as input for this function. And we list them within the opening and closing parentheses. So far when we've created functions, we've just made the open and close parentheses empty. We haven't put anything in there, but we can actually enter parameters. So this says, if you're going to call my output results function, you better pass me 3 parameters. And I am, because when I call the output results function, I'm passing 3 parameters. Parameters are simply items that are required by a function. And we separate them by commas within the parentheses. Up here, they have kind of a picture. We can see what's going to happen. When we call output results, our variables are named original price, discount rate, and sale price. But in our output results function, we've named those variables different things, that's okay. The system will say, oh, output result, you wanted this data, here it is, and it'll make a copy of it and say, the data in original price is now available to you in old price. And it'll copy all of that data to those parameters. So this seems like a really good time to use our visualizer site. Let's copy this code. And let's go to that Python tutor site. And this is exactly why we want to be able to visualize our execution so we can see what's going to happen. So when I start, it's going to scan down to the end of my comments. And when I click next, it's going to process our output results function. So it's not going to do anything with it. It's just going to make note that it exists, right? And have it all set up in memory, ready to run. So there we go. When I click next, my output results function is now set up as a function that requires these 3 parameters. When I click next, we're going to set up our main function. In our main function, we have some variables. So let's see what happens with it. Just set up our function just the same way. So we haven't done any execution of any lines of code yet. The preprocessor has just got everything set up and says, oh, there's a function in this program named main, and there's a function in this program named output results. I'm ready to use them. So when we click next, we're going to execute our main. So we're finally going to start running the code. First thing we're going to do is set up a variable named old price, and it's going to have a value of 200. Then we're going to set up a variable named rate, and it's going to have a value of 20. And then we're going to set up a variable named new price, and it has a value of 160. And now, finally, we're going to call our output results module using those variables. So notice how our output results module gets its own place in memory, and it has its own set of variables. But those values were copied down so that our module can use them. But they're separate, right? They're local to the function they're in. So if I keep executing in our output results module, we'll see it print out the original price, then the discount rate, and then finally the sale price. It returns or gets done basically, quits being indented is the end of our function when we're in Python. So control returns to the line of code following the call to our output results function, which ends our program, and then we're done.
Real quick, so with having both of the output results as those different things, just setting them like that in both the output or in the first module and the main module, does that then automatically equate them to each other? Well, I mean, like, or sorry, I mean, of course, like how you're explaining it, like it kind of equals it. So just like it's like a clone.
It's like what?
It's just like a clone, basically, just slightly modified. Sorry.
Yeah, no, I think that's a good, no, don't be sorry. I think that's a good comparison of what's happening, because exactly it's saying that I'm not going to give you access to this old price variable. I'm going to give you a clone of it. And that really is a good way to refer to it.
Yeah, because I was just trying to like think of some kind of metaphorical thing.
Yeah.
Like, okay, how can I mentally connect this to me so I better remember it? So
Yeah, I think that's a good way, because in memory we have it twice now. Once for in the main and once for in our function. Whenever our function gets done running, that one is going to go away. The clone will disappear. It will be gone now, and we'll only have the ones that were in our main function. So that makes sense?
So the order that you have them in is what lines them up with the
Exactly.
main module.
Exactly.
Now, is it important as to where you have them in order in like when you have them in the output results, you have them in that parentheses there. Is that where that like clones the one in the main module to old price? Like original price is first in the parentheses in the output results.
It's actually
Or is that the bottom?
this header here, our function header, determines what order they should be in.
Okay.
So anything else that refers to our output results function needs to look at this header to say what order they should be in. So when we call it down here, if we put things in the wrong order, let's try it. Right now, we're saying that our original price is 200. If we switch those, whoops, see if I can. It's going to work fine, but we're going to get invalid results. So let me run it, and you'll see that instead of 200 as our price, we got 200% as our discount. That's a really good sale, right? We all want to go to that sale. So the order is what matters.
Okay.
And yeah, whenever we declare our function, that's setting the rules. And so if we decided we don't like it in that order, we could change that function header, but then we would have to change it every place we call it or use it. Good. So I'm going to put that back because I don't want to tell somebody else to copy this and have it be wrong. But you should be able to run that one as much as you want. Use it for experimenting, try things. You know, it's like we're saying, try some different setups and see what happens if you do things in a different way. Let's try another one though. Here we have one where we've got a little bit more pseudocode, and they've given us some comparison pseudocode. They've got two versions of the output results module here. And remember, we're looking at the pseudocode language here. Just like sometimes we might be looking at the English language. You know. The differences we have here are kind of like the difference between English and ye old English, right? Ye oldie Englishy. You're going to be able to figure it out, but it's going to take you a little while. You can't really say, well, I would prefer, you know, ye new Englishy over ye oldie Englishy, but really in the end, it's all the same. So here we've got it. In this example, our output results function uses these variable names, old price, rate, and new price. It uses its own variable names. It's like, to heck with the other modules in this program. I don't care what they're calling those variables. This is what I'm going to call them. This pseudocode down here uses the same variable names as the main, theoretically. That's what they're telling us anyway. So it would work too. It just uses different variable names. So either one is fine. Our textbook says they prefer you to use different names so you totally realize you're making a clone or a copy of these variables in memory so that it's clearer to you. Some students struggle with this concept, so they like to use the same names in the function as in their calling function, and that's fine too. But you can do it either way. So either way is fine. I know sometimes students are like, why'd you show us both? Because I don't want you to look silly when you get in somewhere and you see something that's different than you've ever seen it before. Now, the next section here, figure 9.2, shows us how to call output results. Now, in that call, and again, it's a pseudocode call, it's not a Python call, but here, oh, I'm sorry. This is where we're actually declaring it. It's not a call to it. That's an error on my part. The bottom line is the call to output results could look exactly the same, whether it's calling this version or this version. Because when we call it, we don't care what those variables are named. We just care about how many of them there are and what position they're in. Variable 1, variable 2, variable 3. Okay? So for this little section, I want you to give an explanation in your own words of how arguments are passed to or imported by a function's parameters. And we're going to be looking at it some more. So I'm going to spend like a lot of the day today, 2 hours, trying to explain this to you, how arguments are passed to and imported by a function. And we're going to spend more time about it next time, probably in a week or so. You're going to work on it really hard while we're gone. But then in the end, I'd like you to try to come back and summarize it in your own words, kind of very succinctly, so that I understand if you have any sort of understanding of the concept or not. All right. So that's all I want you to explain there. Not to be mean, and I don't want a book. I just want you to try to summarize. So here's another one. This one will give us a little bit more experience working with functions. The horse of a different color. In our pseudocode, we can see that we have a function here named animal. And all our function does is print out some information. The pet you are buying is a whatever color it is, then a space, and then whatever type of animal it is. So that's all we're going to have here is that little function. And then we're going to call it so we can experiment with sending different parameters. So let's write this one. If I can get to it. I'll go back to trying to do good comments. This is our horse of a different color. I'll leave all that other info out. So we see right away that we want a function named animal. Again, when we're working with Python, they usually make their function names lowercase. We know that we use that def keyword to define a function, and we've just been putting empty parentheses. Now we're seeing that we can use variable names within those parentheses to specify the parameters that we need to be passed to this function. So for this one, they say that we need the color of the animal and then the type of beast that it is. I'm going to put a comment out here to the side. This is my function declaration or header. It has the function name and then parameters. And parameters are those variables that we expect to be passed to this function or imported by. Now, because I put a comment, it's not indenting for me properly. So I'm going to press tab to make sure that my code is indented within my function. All my function needs to do is print out that message. The pet you are buying is a, and then we're going to add our color, and then a space, and then the type of animal. So we should get, you know, like black cat or whatever. Now that ends our function. We could put some comment code down here, end of function when we quit indenting. And this is just so different than our pseudocode, you know. So we don't have any sort of statement that says end function. We just stop indenting, and that does it. So let's create a main. And in our main, we're just going to call our animal function. And instead of setting up variables, we're just going to hard code a couple of values. So let's just say we're going to do this for a duck that is yellow. So here is our function call. So whenever we have a function call, we just, in our code, put the name of the function, and that makes that connection. Python's like, I don't know what an animal is. Is that something that's been defined? Oh, yes, it is. I will go execute that thing that's been defined. So our function call includes the function name and arguments. And arguments are the values that we're passing to this function that will become the function's parameters. If I can say that right. 47 words. So we should be able to just put in a call to our main and then run. Now, if everything's good, I should see the pet you are buying is a yellow duck. Oops, went a little Mandalorian there, huh? Why is that? Because they're in the wrong order, right? So could I switch them? My comma has to go in between, because remember, that's how the system knows the difference between our different arguments. I'm going to run it. And now I've got a yellow duck. That looks good. So notice I just am using inline values that I would say hard-coded values, right? Because I'm not prompting anybody for input on what kind of animal they want. I just have it hard-coded in my code that it's a duck. So nobody be able to change that. Every time I run this program, it's going to be a yellow duck. We could use a variable if we wanted to. So let's say I have a variable of my beast, and we decided it was going to be, what are those one things? I can't think of anything today. That's a hard thing to spell. That's what I kept coming up with. Hard things to spell. Platypus, is that right?
Yeah, that's right.
It's close. And we'll see.
I think it's, yeah, I think platypus is perfectly fine, actually. I think that's correct.
Yay. We'll say it's purple. So could I, instead, I can put a variable here. So I could pass in the value purple that was a string that was just hard coded. And then I could pass in the name of the animal as a variable. So I can be super flexible that way, you know, when I'm passing in arguments to my functions, however I want. All right. So I could have numbers just in stream, like if I'm calling a square root function. Questions about that one? Does it work for you? Got it? I want you to have it as example code so that you can experiment with it and play with it and try things. So sometimes when we look at our pseudocode, they'll add a data type to the parameter declaration, and then that gets really ugly to look at. Things can get really ugly when we first start exploring code, and then we get used to it. You guys have seen that, because that first day, a lot of people look at me like I'm crazy enough, and this is your pseudocode, and now you guys just look at it and read it. Well, that's how this is. In this example, we have a string that we're going to surround with symbols again, because we want to make sure everybody's ready to do that back thing. But in this one, where we declared our function, instead of just saying words is the name of our parameter variable that we want, we've mentioned the data type too. Some programming languages require that. So sometimes you'll see it in our pseudocode. Python doesn't require it, so you don't have to put it in our pseudocode. But it could be confusing for you if you see it. So when I look at this, how do I know that this is a variable named words that is a data type of string and not two variables, one named string and one named words? Well, I know because there's no comma. So since there's no comma, I know this is one variable with its data type. Does that make sense? Because otherwise, as a new programmer, you really have to look at these things as things that you're not sure what to expect. So I'm going to look at, anytime I'm looking at a parameter list that's within parentheses, I'm going to be looking for those commas to know how many different parameters I need, because I might be running into a data type. So for this example, let's do it in Python, because it's a little different in Python again, just like it would be a little different in any programming language. That's part of it. Part of the fun is learning the new languages. Let me get a snip of this one so I don't have to keep going back and forth. Okay. So I'm going to say that this is example 9.4. And I'll call it message string. For this one, we're going to have a function called surround and display. And for our function, we expect to be passed a string variable, and we're going to call that variable words in our function. All our function is going to do is print out those words with 5 stars on either side of them in a space. So 5 stars and a space plus our words variable plus 5 stars or a space and 5 stars, because we want that space to be at the beginning of this. So that's all our function is going to do. Now in the example, they say you might expect to see a data type here in your function. Let me try and run this. I'm not calling it or anything, but I just want to make sure that I don't get any sort of errors. Because you know, if I had something wrong, I would get errors here. So I don't get any errors. But I was trying to figure out a way to say in Python that that's going to be a string. So I thought, well, what if I put str around it? Because I was able to do that in declaring variables. Python does not like it. So we just can't do that functionality in Python. So that's an extra thing to add to your list, is that sometimes parameter variables might have a data type in front of them that we don't do in Python. This morning in the SQL class, I was explaining to people how it's harder to determine when we don't have data than it is when we have data. Right? Because if I know how old you are, I can figure out how old you are. But if I don't have that data, that's really hard for me, right? I'm just kind of shooting in the dark. We need data. Well, this is one of those kinds of data things that's a little too much for you. And I apologize that sometimes you get too much info right now. But I want you to get into your head where you're aware that within parentheses of parameters, I might have data types. All right, let's run our function that doesn't include the data type. So I'm going to set up a main. And in our main, let's prompt our user for a message. Enter a short message. And then we'll use our surround and display function to print out that message. I'm going to run my main. So let's try it. Oops, I left out kind of that important def word. Okay, so here's our message, short message. And then we see it printed out with stars all around it. So far, we've been looking at how to call our subprograms. And we've been talking about things being sort of like a clone. And I think that was a really good description. I think I have this up. Okay, I'm looking at the smartboard and I'm going to see if we can use this.
Draw a platypus.
I can't find the calibrate thing, so when I draw, it's way over here. Otherwise, I could, totally. It's just a smartboard problem. We've been looking at that visualize application, and it's really helped a lot. But to me, we have some memory, right? That's what that visualizer thing has been showing us. We have memory, and everything's all about memory when we're working with computers, right? That's why we always need more RAM, because it's all about memory, because that's where all my stuff is. So if I create a variable 1, it's allocated in memory, right? So it has some space, variable 1, you can't read that. And then I give it a value. Let's say I make it equal 7, then 7 is going to be placed in that spot in memory, right? So that's how things are working. We have this location in memory, and we have associated it with that variable name. So if I could write really teeny with these things, which I can't, but I'll try, I could see that variable 1 was actually in location like 0, A, H, or something like that in memory, right? A memory address, and that would point to that actual variable. So we've seen that when we call a function, and we have our function down here. I just clicked on something. I'm moving things instead of drawing. Stop it. I have my function. And in my function, I've said I want variable x. Let's make it x because I can't write anymore. And so we're going to pass variable 1 in as x. What's going to happen over here? We're going to have a new place in memory allocated for variable x. And it's going to have that value of 7 put in it. And now in our function, we can do whatever we want to x. We can multiply it by things, divide it by things, loop with it, do all sorts of stuff. But when our function is done, that variable is going to go away, right? And our original variable 1 up here that was in our original function is still going to be sitting there just the way it was. It's going to be completely unaffected. Right? So whenever we do that and we pass data in that way, that's called passing by value. And that's the default way data is passed from one function to another by value. This value of 7 is copied down or cloned into this new memory location to be used by that function, right? So it all makes sense. We can think about it. My goodness, if I'm an airline and I have something that has 7 billion customers in it, are they all going to be copied when I call a function? Oh, those are things to be concerned about, right? Because we could use vast amounts of memory when we call these functions because we are cloning our variables. But that's something for us to think about on another day. For today, we want to understand that passing by value is the default way data is passed from one function to another, and that means we make a copy of things. There's another way though. If we pass by reference, then, let's see if I can erase this without mangling everything. If I pass by reference, my function now down here that's waiting for this variable x, instead of getting a new one allocated in memory, instead it's going to receive the reference or memory address of the other one. So now it's going to be told, oh, you're at location 0AH in memory, and variable 1 is going to be pointing to that location, And so is our function, our variable x. Now, when x is running and it does things with this variable, multiplies it by things, uses it in loops, does all these things, it is updating this actual memory location that is shared by the calling module. This is passing by reference. Some old C compilers, things like that, might pass this way by default. So we have to be aware of what's going on with the language we're working with. Most modern programming languages pass by value unless there's a specific parameter used that says I want to pass by reference. When we pass by reference, we're almost like making this variable back into a global, aren't we? Because we're saying, oh, I'm going to stand alone, but I'm going to update this stuff for this other function. So we're sort of getting away from our standalone idea. So that's why we don't see this used very often. But again, it's something we need to be aware of, passing by reference. So in our textbook, it has some information to explain that to you. And whenever we're looking at example 9.5, let's try this one together. In 9.5, we're going to do a standard pass by value. So I'll put that in here. So we don't want a whole lot. Let me snip it. Flipping everything around backwards to make it into Python for us. And we're going to start with our function change value. Our change value function wants to have a number passed to it, and it's going to call that number number. It's going to update it, and that's it. That's all it does. So our main is going to set up a different variable called number1, and it's going to set its variable equal to 1. And then it's going to use our change value function, passing the number 1. And when we get back, we're going to print it, our number 1. Now this should be pretty simple. Let me call our main. When we start up, our number 1 variable is going to be set up to be allocated to 1. We're going to pass that variable to our change value function. Our change value function is going to make it 2 and be done. When we return to our main, or continue on, we'll print out that value. Is that value going to be 2, or is it still going to be 1? Be nothing because I put a semicolon there. How about fix that? It's 1. Because again, we passed by value. So our values are completely separate. They're clones of each other. In the next example, they show us how to pass by reference. The only way we can do that with Python is if we're using a list type variable. And we haven't used list type variables yet. So we're not going to try to do an example. But I think that you understand, or I hope you do, and just kind of try to tuck it away back in your memory, that if I pass by reference, see this keyword as ref here? If I pass by reference, now my arrows are going both ways. I'm receiving that variable and I'm updating that variable, and it's like a global. So it's a bad thing. It's not something we like because we're trying to make each of our functions completely stand alone. And if we start using reference data, now we don't stand alone anymore. So we don't have an example for that one, even though it says we do. Now in 9.7, this is a huge one. I just sort of scrolled past it for the other class because I want you guys to take a look at it, but I'm more concerned about your quest. So we're going to scroll on past it. Now in section 9.3, our textbook refers back to the built-in functions that we have looked at just recently. So as it revisits these functions, it wants to point out to you that these functions are built in. They're part of our programming language. They came with it. We didn't have to buy any expansion packs or anything, right? It just came with Python. So any function that is part of the language is considered built in. When we create functions, though, these are user-defined functions. So we're creating our own. So be aware that that's a difference in the type of functionality. If I took my Python code to another facility, another computer, and I ran it, I would have access to all of the built-in functions, but I wouldn't necessarily have access to any user-defined functions unless they were included in my code. So as we look at functions, we've seen a few different ways to pass data to our function. So we know how to give our function input. How do we get our function to output something? Say we're writing a function, like in this case, to do a cube of something. We want to do a cube root, or take a number to the power of 3 is what this function is going to do. I would like to get the answer back. So I want to know, how do I return an answer back to the function that called me? So let's do the code on this one and then we'll compare it. If you look at 9.14, you see the cube function is already created for you, but I think it's created wrong. Try it. Yeah, I tried to declare that data type and it won't let me. So get rid of that word float. We can only have it pass us aside. And then what else is wrong with that code? For 2 lines of code, I can fit in a lot of errors, huh? Is it %%? What was that did the power of? Do you guys remember?
The arrow. Power is 2 little dots. The 8, yeah, like that.
Yeah, I think it was 2 stars, 2 asterisks, I think. When I was doing it Sunday evening, I was pretty sure it was % signs. I thought, well, we could do some debugging, get those ducks out anyways. All right, so you got it fixed now. So now we have a function that is at least not got syntax errors. This function is going to accept a number that's going to be the size of a side, 1 cube. And then it's going to take that to the power of 3. And we've got this new keyword, return. What that keyword says is, whatever the answer is, just return it to whoever called me. So again, putting it out in memory so that the calling program can do something with it. So let's try some things with that. I've got my cube function. I can use it. They used it. They call it with a number of 10. We can do that. Little box. I think I'm going to wait for a second. Let me just call it, giving it a number of 10. How about we print out the answer? So I'm going to use my cube function and I'm going to pass it a number 10. It's going to take 10 to the power of, to the 3rd power and return that to me, and I'm going to print it. Let's run our main and see how that works. Good, that looks good. This looks like a good one to copy into our Python tutor site, doesn't it? Let's copy it. So in our Python tutor site, I'm just going to click Visualize Execution. First, we're going to see our cube function get defined. Then we should see our main function get defined. Now we're ready to start executing our main. In our main, we're going to call our cube, and we're passing it a value of 10. So its side variable that's local, that's only available within the cube function, is set to 10. Now we're going to take it to the power of 3, and there's our return value. Notice that the visualizer is like, well, I'm not exactly sure how to explain this to you, so I'm just going to put this here in memory, that I have this return value of 1,000 that's ready to go someplace from this return statement. So let's continue on then. We go back to our print statement and print out that returned value. Notice how now it says none because we've left that function and we're back in our main. So I was able to call our cube function and print out what it returned. What if I wanted to save what it returned? I'm going to go back to my cube function, and let's say I want to create a variable like they did called little box. What I can do is set little box equal to the results from my cube function. Now I can go ahead and add another line of code to print that out. I should see the same exact output as I saw before, that 1,000. So the outsiders don't know there's any difference, but insiders, we can tell. Now we've called this function and captured the output. So let's put a comment there. Call the cube function and save its return value in little box. So if I were using a fancy calculator, a graphing calculator, and I wanted to set up some formula, it would be just the same, right? I'd have to say, well, call the square root, get the square root of this number, but then I want to use that answer to continue on in this formula. And that's what we're doing. We're saying, I need to save that answer in this little box variable so that I can use it later, okay? So if we want to save the return value from a function, we have to put a variable name followed by the equal sign, our assignment operator, right? And then the call to our function. So in effect, we're saying run this function, whatever value it returns, assign that value to our variable. So we have lots of things going on there. Questions about that? Does it make sense? We can run that one in the visualizer too if we need to. Okay, so what about an area function? Let's go to recursiveness, and then we'll come back to that one. Down at the bottom here, I'm going to go to section 9.4. And in this section, we talk about recursion. A recursive function is any function that calls itself. In our example, they use a math problem, so it can be kind of hard to understand recursion because every programming textbook that you're going to run across is probably going to use this same math problem to describe recursion to you. So let's look at recursion in a different place. I'm going to open File Explorer. File Explorer is a recursive process in a sense, right? So a recursive process or a recursive function is a function that calls itself. So I'm in File Explorer. If I want to see what's in my C drive, I double click on my C drive and File Explorer called itself and gave me what's on my C drive, right? Now, if I want to see what's in my program files folder, I can drill down, double click on it, and File Explorer is going to call File Explorer again to display the outputs of that folder, right? That's a recursive process. Now, we don't know the inner workings of it, but it gives you the concept of what recursion is. It's just a function that calls itself. So every time I'm looking at File Explorer, if I want to drill down, I just double click on something and it calls itself again. It gives you a new display. That's a recursive function. So we know what it is. It's not that confusing. It's just something that keeps calling itself. So I think we have time to do this one. Let's try it. The little math problem. I'm going to get a snip of it. Recursion. It's one of those things that you might not ever hear. When I interviewed for a job one time, I was in the interview and they asked me to explain recursion. And I sort of went into panic mode and I thought, what in the world is recursion? And so I came up with the answer that I thought was right. And then as soon as I got out to my car, I Googled it and I was like, whew, thank goodness. But that's how often you'll use it. So in our function here, we're going to name our function sum. And it's going to accept a number. And we're just going to call that number n. All right. Now, something else that our pseudocode is going to do that we're not going to do in Python that you might ask about, this function header in our pseudocode has been updated and it says as integer. That's the data type of the data that's going to be returned from this function. With Python, again, we don't have to do that. So we just say return this value and we've taken care of returning it. Another thing that they do in our pseudocode that we do a little differently in Python, this chapter does have some areas like that, is that notice they don't actually have that statement in here anywhere, return. They've never said return the answer. What they've done is they've used a variable that is the same name as their function name. So when this function gets done executing, that variable that's the same name as the function name will contain the value that gets returned. Python doesn't do it that way. In Python, we will say return this value. Thank goodness, because it's much clearer. So this is kind of an older way of older languages doing the return statement where we just set a variable that's the same name as the function, but that can be kind of confusing. Those are definitely some differences you're going to see between our pseudocode, old school language kind of assumptions, and our Python newer language actual use. So a little bit of differences there for us. I feel bad about them, but then I think, if you're going to go into the world of CIS, that's going to be nothing. You're going to be so used to comparing one thing to another. So in our sum function, what we want to do here is we've been tasked with accumulating all of the numbers. So let's say we're going to start with the number 4. What we want as an answer is going to be 4 plus all of the numbers beneath it. So 4 plus 3 plus 2 plus 1. That's going to kind of be the answer that we're wanting our sum function to figure out for us. All right. So let's create that code. And we can just look at existing code because this is going to be everywhere. The way this recursion works is we work with n and we try to get n to 1. Now I'm going to need an answer here. Probably total. I'm going to create a variable called total. And when our number n that we're trying to sum is 1, the last digit, we'll set our total to 1. Otherwise, we're going to set our total equal to our total. It's got me all whacked out. We're going to have to do this next time because I don't want to waste your time. Let's put a comment there. Do next time. Keep that comment so that we don't forget, because I am going to have to show you the stuff before this so that you can work on your quest. So we'll look at that recursive stuff after I had a chance to make sure I've got the right code, because I'm going to take us off in the wrong direction, and that's never any fun. So let's back up to student activity 9, create an area function. We want to write a function named area. Our function should accept 2 parameters, one for the length and one for the width, and it should calculate the area of a rectangle. Then we want to write a statement that calls this function using any values we want. So I'm going to set my alarm for, let's see, what time is it? 1:08. So for 1:14, that's not very long. See if you can, how much of that you can develop. I don't see much typing. Has everybody got it already? Don't need anything?
I would say there's more of a vomit of random writing, and then now it's just the damage control. It's At least that's what it is for me.
Very good. I'm going to create one. So let's see. They want it to be named area, length, width. That should do it for us. It should make you guys all screen share, and then I can just click and go through them, see what you're doing. But that should be all we need. Like 4 lines of code, and then we'll count that call to our main, I guess, as the 5th line of code. Should do it for us. So we had a lot of stuff. Whoops, there it goes. It's done now. Remember too that whenever you look at something, I love it when students say, it took me 7 hours. It took me 3 lines of code. And they're very frustrated. And I think, that was a 7 hours so well spent. Because look at those beautiful, compact 3 lines of code that you got instead of doing it in 57 lines of code that swirl around and do all sorts of terrible things. When a student really thinks about it and considers it, we can tell that it's going to be much more concise and more organized. This one, there really wasn't any way to go any other way, or was there? We could do all sorts of different things. We could prompt for input. We could display messages. We could do all sorts of debugging things. So this is kind of like the minimum amount. I took your time today, and I wasn't planning on it, but as I reviewed what we were going to do, it just seemed like it was more important for us to look at subprograms today than spend our time with a lab day, although that's very important too. So we reviewed subprograms, and we've got a little bit of an inkling of how they work. The things that we have left over then are the Colab notebook for chapter 9. I scrolled past that one big one, that sale price program, and I said, I'm just going to kind of scroll past this, and we're going to go back to the recursion activity, and I'll get that one for you. You don't have to worry about that. I'll do that homework. But the big thing is your quest. And your quest project is supposed to be a group project. You can only turn that in once for your group. So that means should really work with your group on it. Now, that's hard. Some of you have group members that are scattered. Some of you have group members that you haven't heard from. All sorts of different things. If you're totally on your own, anybody online too, let me know, and I will ask another group to bring you in so that they can help you with stuff, because we don't want anybody working all alone. Now, saying that, I'm not going to rearrange all of our groups and everything, because we're kind of towards the end of our group work, and our groups have been working together really well. So I don't want to just mangle them and switch them all around. But I do know that some of them are suffering. So let me know if you're suffering. The Quest group project is what we need more than anything. So at this point, next Tuesday will be like the first hour of lab time. Then we'll take any questions about the Colab notebooks. We'll look at that recursive one, anything like that that's outstanding. So our second hour, we'll be getting everything sort of clarified, turned in. I'd really like you guys to present your Quest projects to each other because each group is going to have such amazing things. Now, having said that, we're in a very flexible mode. Try to be flexible with our schedule because I think it's really important right now. So if we get together next Tuesday and I'm not seeing the quality work that we need for our Quest project because you guys haven't had a chance to get together, you've been working on all these other things, whatever the case may be, then we'll adapt and we'll adjust our due dates. It's not going to hurt us in the end, but we do want to try to make sure we continue to move forward so that we're getting all of the content in that we possibly can this semester so that we're prepared to move forward to our advanced classes. Now, on the side, you also do have some Chapter 9 review questions. They're new out there for this week, and there are many fewer of them, if that's proper English. I'm talking Mandalorian again. But there are very much fewer of them than there have been in the past. Don't forget, you can do those things more than once. So save your answers. And if you want to improve your grades, you can, because they're kind of a study guide thing, more so than a one shot and you're done kind of thing. Questions? We just run right up to the edge every time because I only get to see you guys once a week.
It's not really about any of this stuff. It's about the last week, the Padlet.
Uh-huh.
It's not saving answers all the time.
Is it not?
No, I put in a couple and
Oh, let's check.
she just alerted me that they did not save.
Well, I will check and see if it's wanting me to do something.
And I did it.
Well, I believe you. I totally do. I'll check it. Any other stuff? Let me know. Like I said, I know we're moving fast and I'm just kind of trying to hang on like you guys. So let me know if we're stuck on something so we can review it. But that's all I got. I'll see you next Tuesday. Do get with your groups and try to be getting as much of this stuff done as you can. And I'm going to go look at this Padlet thing.
So, part of it over. So, and then,